Good day, everyone. In today's discussion, I will be explaining the process model. Here are our learning outcomes for this discussion. Let us first discuss the social learning process. Software is embodied knowledge that is initially dispersed, meaning scattered or spread, tacit, and incomplete. Now, in order to convert knowledge into software, dialogues are needed between users and designers, between designers and tools to bring knowledge into software. Lastly, software development. This is essentially an iterative social learning process, and the outcome is software capital. Before we continue, let me refresh your memory on what the word framework means, for we will be using this word often in this topic. Keep in mind that framework is the standard way of building and deploying applications. Again, framework is the standard way in building and deploying applications. We now go to software process. We define software process as the framework of activities, actions, and tasks that are required to build a high quality software. Building a high quality software will be very difficult, if not impossible, if we do not have the right software process because it defines the approach that must be taken as software is being engineered. Now, let us define process flow. Process flow describes how the framework activities, actions, and tasks occur within each framework activity and organized with respect to sequence and time. There are five framework activities: communication, planning, modeling, construction, and deployment. There are different types of process flow, namely linear process flow, evolutionary process flow, parallel process flow. So let's discuss them one by one. So the first one is the linear process flow. The linear process flow executes each of the five activities in sequence as what is being showed in the diagram. So the execution of the during the linear process flow is, as you can see, straightforward. The second process flow is the iterative process flow. The iterative process flow repeats one or more of the activities before proceeding to the next, as shown in this diagram. The third is the evolutionary process flow. So the evolutionary process flow executes the activities in a circular manner. Each circuit leads to a more complete version of the software. The fourth is the parallel flow or the parallel process flow. The parallel process flow executes one or more activities in parallel with other activities. So, for example, or as shown here, communication and planning. So, after the communication, as you can see, the modeling process or activity is already being on the way, underway. So the parallel process flow executes one or more activities in parallel with other activities, modeling for one aspect of the software in parallel with construction of another aspect of the software. Now, we go to uh, why process, or let's answer the question why process model. So, why process model? Why do we need to learn about this? Why is it important, or why do we have to learn it? The reason for this question is because a process model provides stability, control, and organization to an activity that can, if left uncontrolled, become quite chaotic. However, modern software engineering approaches must be agile and demand only those activities, controls, and work products that are appropriate. Process model provides a roadmap that helps you create a timely, high quality results. Now, you might ask if there is a fixed or particular process model when building a high quality software. The answer to that question is no. The process you adopt depends on the software that you are building. One process might be good for let's say for example an aircraft avionics system, while an entirely different process would be used for website creation. So there is no definite process model. Now, how would you know if your process model is right? Simple. There are a number of software process assessment mechanisms that can be used that will enable us to determine the maturity of the software process. However, the quality, timeliness, and long term viability of the software are the best indicators of the efficacy of the process that you use. Now, let us talk about generic process model. A generic process framework for a software engineer defines five framework activities. As we have discussed earlier, you have communication, planning, modeling, construction, and deployment. A set of umbrella activities: project tracking and control, risk management, quality assurance, configuration management, and technical reviews and others are applied throughout these umbrella activities. Let me zoom in there, as you can see. The question now is how the framework activities and the actions and tasks that occur within each activities are organized with respect to sequence of time. The answer is what we have already discussed, which is the process flow. The process flow, if you may recall, these are the linear process flow, iterative process flow, evolutionary process flow, and the parallel process flow that we have discussed earlier. Now here is an illustration of those process flow: the linear, the iterative, the evolutionary, and the parallel. We now go to task set. Okay. So a task set defines the actual work to be done to accomplish the objectives of a software engineering action. A task should answer the question: what actions are appropriate for a framework activity given the nature of the problem, the characteristics of the people, and of course, the stakeholders. A task set defines the actual work to be done to accomplish the objectives of a software engineering action. Okay? This includes a list of tasks to be accomplished, work products to be produced, and quality assurance filters that needed to be applied. Here is an example of a simple task set. So let's say, for example, a small software project requested by one person with simple requirements. The communication activity might encompass little more than a phone all with the stakeholders. Therefore, the only necessary action is phone conversation. The work tasks of this action are: number one, okay, you have to make contact with the stakeholder via telephone, discuss the requirements and take notes. Number three, organize notes into a brief written statement of requirements. And yung fourth one is to email to stakeholders for review and approval. So, as you can see, these are the steps. Okay, we are talking about steps. Okay, task set. We call it task set. But these are the steps that you need to follow for a process model. Another example of a task set for elicitation. So, for the task set, okay, so the task set for requirements gathering action for a simple project may include: number one, make a list of stakeholders for the project, invite all stakeholders to an informal meeting, ask each stakeholder to make a list of features and functions required. Next is discuss requirements and build a final list. Number five, prioritize requirements. And number six, note areas of uncertainty. The next slide is another example of a task set for a more complex software project. Okay, number one, make a list of stakeholders for the project. Number two, interviews each stakeholder separately to determine overall wants and needs. Number three, build a preliminary list of functions and features based on stakeholders' output. Number four, schedule a series of facilitated application specification meeting. Number five, conduct meetings. Number six, produce informal user scenarios as part of each meeting. Number seven, refine each user scenario based on stakeholders' feedback. Number eight, build a revised list of stakeholder requirements. Number nine, use quality function deployment techniques to prioritize requirements. Number 10, package requirements so that they can be delivered incrementally. Number 11, note constraints and restrictions that will be placed on the system. And number 12, discuss methods for validating the system. So those are the steps. Now, again, this is not a fixed step or task set. Okay, it will depend on the person who is creating the task set for a particular project. Now we go to our next topic, which is the process pattern. A process pattern describes a process related problem that is encountered during software engineering work. It identifies the environment in which the problem has been encountered and suggests one or more proven solutions. So we have three process pattern types. The first one is the stage patterns. Second one is the task patterns, and the third is the phase pattern. Okay, we'll have a or we'll be discussing process pattern templates on the next slide. So, one of the requirements for a process pattern template when you're creating a process pattern template is the types or type of pattern that you will be using. So before we go there, let's discuss these three pattern types. First one is the stage patterns. A stage patterns defines a problem associated with a framework activity for the process. It includes multiple task patterns as well. For example, establishing communication as shown to you in the task set, the first task set example, okay, which is establishing communication would incorporate the task pattern requirements, gathering, and others. So you have to do some interviews. Next, number two is the task patterns. Okay, defines a problem associated with the software engineering action or work task and relevant to successful software engineering practice. Number three, okay, we have the phase patterns. Now, the phase patterns defines the sequence of framework activities that occur with the process, even when the overall flow of activities is iterative, meaning you can change it, okay, in nature, or it can change, okay, in nature. Example includes spiral model or prototyping. This has been the spiral model or prototyping has been discussed to you in your systems analysis and design subject. Okay, now we go to the process pattern template. So when you create a process pattern, okay, you have to make use of this template. So these are the different activities, different actions that you have to place in a process pattern template. Okay, the first one is the pattern name. Okay, the pattern is given a meaningful name describing it within the context of the software process. So example of a pattern name is technical reviews. Okay. Next, number two, forces. The environment in which the pattern is encountered and the issues that make the problem visible and make effect its solution. So that is number two. Number two is the forces. Number three, okay. For number three, okay, we have the type. Okay, so we just discussed the three types, okay, that you can use for this or when answering this. Okay, we have the stage, okay, we have the task, and we have the phase pattern. So all you need to do is to choose which of the three you will be using or what type you'll be using. Number four is the initial context. So the initial context describes the conditions under which the pattern applies. Okay, number five, problem, okay, the specific problem to be solved by the pattern. Okay, next, number six, we have the solution, of course. Okay, so you have the problem and then you have the solution. Okay, so describes how to implement the pattern successfully. Okay, number seven, resulting context. Okay, describes the condition that will result once the pattern has been successfully implemented. Number eight, okay, we have the related patterns, provide a list of all process patterns that are directly related to your to this one. Okay, and number nine, you have to know uses and examples. So you have to indicate the specific instances in which the pattern is applicable. Okay, so we have the process assessment and improvement. Okay, the process assessment and improvement. So Software process cannot guarantee that software will be delivered on time, meet the needs, or has the desired technical characteristics. However, the process can be assessed to ensure that it meets a set of basic process criteria that have been shown to be essential for a success of a software engineering. Okay, so these are the four assessments that can be used. Okay, to check the software process. You have the standard CMMI assessment method for process improvement. We have the CMM based appraisal for internal process improvement. We have the SPICE, and we have the ISO 9001 2000 for software. And that's it. I hope you learned something, and thank you for listening.